Oh,
wait,
I'm sorry.
record now. Off to you.
Hey, alrighty. Hey guys, thanks very much for inviting us to do this demo. My name is Mitch Kate. I'm part of the U.S. based team here for Nodeweaver, responsible for primarily for sales and strategic partnerships. My U.S. based colleague Tom Mays is also on the call, and we are also joined by our CEO and CTO. Carlo De Fara is our CEO, and Lorenzo Falaschini is our CTO, both of whom are based in Northeast Italy, and that's where most of our technical operations reside. So we're happy that you've given us the opportunity to present Nodeweaver. I'll go ahead and turn it over to Carlo De Fara just to run through high-level overview of Nodeweaver, who we are, what we do, and then he'll turn it over to Tom for the technical demo. And the first part of the technical demo is going to show basically how easy it is to set up and deploy Nodeweaver on Equinix Metal. And then the second half of the demo will be showing you the Nodeweaver interface and going through some of the high-level features and functionality, and then after that we'll open the floor for any questions. So if that sounds like a plan, I will go ahead and turn it over to Carlo.
Thank you so much. It's a pleasure to be here. Nodeweaver is a platform that has been created to address a very specific need, which is the need of managing applications and data processing across a wide range that moves from the central, the public cloud, to the data center, to the edge. The edge is where we expect the majority of growth to happen. And one specific thing that is essential for managing workloads at the edge is the ability to provide a way to manage application that is basically the same as the public cloud. So you're basically abstracted from managing the physical hardware, being able to deploy application in every edge location and manage them all at once. Nodeweaver is a platform that is designed to provide this kind of cloud capabilities for a wide range of workloads. Going from traditional VMs, which are still used by the majority of current adopters, the ability to run Kubernetes applications and containers, and includes a full set of services that are designed specifically to address the need of management of these applications in many locations at once. So the ability, for example, to reach any edge cluster from anywhere, orchestration, and especially autonomy, the ability to handle things on its own without having a dedicated operator that goes from one edge location to another to manage things. This autonomic aspect, the zero touch and zero management aspect of Nodeweaver is probably the most important differentiators compared to other solutions in the market. The system does have its own system called the autonomy engine that provides zero touch management for whatever kind of workload without requiring user intervention. We do provide remote management, the ability to handle any kind of workloads, including real-time workloads, are very important for things like real-time packet processing or for industrial control. We do provide a very small package that fits in less than 1 gigabyte of memory, but does provide everything that a cloud needs to provide: software-defined storage, software-defined networking, orchestration, remediation, alerting, and the ability to connect to common APIs and services like Ansible or Terraform. We are designed to reduce the management cost in the lifetime of the workloads. So to have an easy deployment, to reduce the cost of management as much as possible, and to be fast and efficient without wasting resources for running the platform itself. We require less than 1 physical core and less than 1 gigabyte of memory, so we are pretty lean in this sense. We have more than 400 deployments in 15 countries with a wide range of workloads that goes from remote management and automation for wind and solar farms to real-time workloads for deep learning, weld inspection, industrial controls, smart video, which is one of the very important workloads for security and law enforcement. And we do have a huge request for network function virtualization that goes from straight and simple SD-WAN services to complex network orchestration. For example, in the maritime sector, where you have cruise ships that move from satellite to port-based networking, and you need a way to present all of this as a single transparent network. We do have a fairly good showing in the major analyst groups. We have been, let's say, blessed to be winning some prizes in the last few years. And we continue to invest in research and development with the roadmap that focuses in the next 2 years to strengthen and increase our capability of remote management and global management. With this, I will move to Tom for the rest of the session.
Super, thank you, Carlo. So as Carlo mentioned, Nodeweaver is a software-defined operating platform that installs on the bare metal of Equinix servers and turns them into nodes in a compute cluster with just a few clicks and in a matter of minutes. And that's really what we're going to show you today. We're going to demonstrate how easily you can automate the turnup of a new Nodeweaver cluster, complete with automated deployment of an entire application stack, and also integrated with fleet monitoring of all of your Nodeweaver cloud clusters across different Equinix Metal locations. From power on to cluster ready takes only about 10 minutes, but in the interest of time today, as Mitch mentioned, in the first half of this demo, we'll show you the 3 main phases of a cluster deployment on 3 different Metal servers. And then in the second half, we'll show you the Nodeweaver user interface and some of the features and functionality. So starting with Nodeweaver installation and configuration, the first Metal server that we've provisioned is already pre-installed and configured as a cluster with an automatically deployed application stack that's already running. So a set of virtual machines that we've already automatically deployed as part of the deployment. The second server has Nodeweaver installed, but is not yet configured to be part of the cluster. And we'll start with the third server, which is blank and really booted only into the rescue operating system. To install Nodeweaver on a blank server, you simply go to the Equinix Metal section of our documentation and copy the 1-line script. Then in the out-of-band management console for that server, log in as root and simply paste the 1-liner. The installation process will start immediately and we'll download and install the latest version of Nodeweaver on the server and then reboot. The second server shows the state immediately following this reboot. Nodeweaver is installed and booted and waiting for it to be configured. Before beginning the setup process, you want to go to the back to the Equinix UI and go to the Metal Gateway, which we've set up in advance. Here, you'll copy the IP block. This is the only information that you need to provide to configure this node as part of the cluster. And what you'll also notice is that we've pre-allocated a range of IP addresses that we're reserving for use by virtual machines running under Nodeweaver. So back in the out-of-band management console for this server, we log in as setup and simply follow the prompts. Configure this host, and then paste the IP block that we just copied from the Metal Gateway. From this point, configuration is automatic, after which the server will reboot and automatically either elect itself as the cluster leader if no other Nodeweaver server on the local network has already done so, or if it finds an existing cluster at the IP address that was defined in the IP block, it will join it automatically and start automatically leveling storage, replicating storage across the different servers, and leveling workloads across the newly available resources. Once the first node in a cluster comes up, as mentioned, it will look on the local network and try to find an existing server, an existing Nodeweaver server at the IP address specified in the IP block. If it doesn't find a response to that IP address, then it will elect itself as the cluster leader, and it will raise that cluster management IP address. Other than the reserved IP addresses that are used for virtual machines, Nodeweaver only needs one IP address per cluster, regardless of how many servers are part of the cluster. Also, if an email alert address is configured for that cluster, you'll also receive an email directing you how to reach the cluster. Once the cluster leader is elected and it raises that IP address, you'll receive this email, which specifies both the local IP address at which you can reach the cluster, as well as a remote proxy address that you can use to reach the cluster from anywhere remotely. The Nodeweaver UI is web-based. So to access the UI, you simply open your browser and go to either the IP address specified in the email in the IP block, or to the remote proxy address that was specified in the email, and log in. At this point, you notice that we have only a single node in this cluster. The second node is in process of rebooting and coming up and joining as the second node in the cluster. Nodeweaver is designed to run any workload, including, as Carlo mentioned, both containerized and traditional virtual machine-based workloads, but to run them nonstop, self-optimized, fully autonomously, and with no human intervention. The automated deployment for this cluster was also configured to automatically download and start the set of virtual machines shown here. So no system administrator was involved in standing up this cluster other than the few copy and pastes that were necessary. The configuration of individual virtual machines are defined by templates, which define the compute resource allocation, virtual hard drives, virtual networks, and other specifications that define how the associated virtual machines will be configured. Service templates also allow you to combine together multiple virtual machines into application stacks that ensure that interdependent applications boot in the right order. And service stacks also support elastic services, for instance, Kubernetes, that need to scale up and down automatically. For example, this is Kubernetes K3s service stack from the Nodeweaver marketplace that includes both master and workers, and that is configured to scale up and down automatically as load conditions change. If you like, you may also, in addition to the Nodeweaver marketplace, you may also configure custom private marketplaces where you can pre-configure your own virtual machines and distribute them from there. Everything in the Nodeweaver graphical user interface is backed by an API call. Nodeweaver can be managed programmatically, and nearly every aspect of a cluster's configuration can be customized via a set of key value pairs called attributes. For example, the email alert, alert emails attribute is configured in this example, and it defines where to send email alerts for the cluster. There's a full list of supported attributes that is shown in the documentation. Another very important attribute shown here is the bootstrap script. In addition to the full-featured API, the Nodeweaver bootstrap system supports automatic cluster configuration via low-code scripting, allows you to configure fully automatic deployment of new clusters from power on all the way through running application stacks with no human intervention. So by this time, the second server has finished installing Nodeweaver. The first server has finished installing Nodeweaver, and the second server has configured itself as a follower node in the cluster and joined as a second node. And you'll see that it's already automatically started leveling storage and distributing virtual machines across the newly available resources. So as storage finishes replicating across the two servers, you'll see that the storage comes up into a stable state where every block of data that's on the first server is also replicated onto the second server. Nodeweaver also includes, at no additional cost, Edge Insight fleet monitoring system to help manage your Nodeweaver instances across Metal sites. In this demonstration, we configured the bootstrap script to automatically start a local instance of Edge Insight, and then automatically link the VMs and applications to that local instance automatically. We also configured it to automatically uplink the local site to a centralized instance of Edge Insight. Edge Insight allows you to monitor your Metal servers, but also the virtual machines and applications that are running locally, as well as across all of your Metal locations. So this is an example of the local site showing all of the virtual machines that are running, and whether there are any issues on these servers. And this is the central site showing multiple locations around the world, and gives you the ability to click through and manage individual sites if you get any red-green notifications. You can also see all of across the entire fleet of locations, you can see any issues that might need to be addressed. Edge Insight also includes a full time series database, allowing you to go back and identify the cause of any issues as well. So as you can see, it takes just a few minutes and a few clicks to easily turn Equinix Metal servers into a fully operational, highly available, and scalable private cloud cluster. It's so easy, really, just about anyone can do it, and we hope that your customers enjoy trying it out for themselves.
Awesome.
At that point, we're happy to take any questions.
Thanks, Tom. I'll field this to our SC teams, to Ben or James. Maybe you guys want to go first.
This looks fantastic. Thanks so much. What a great setup. I mean, seriously, I don't have anything specific.
Okay.
Yeah, nothing on my end.
One question I had is just how do you, maybe you may have covered this, but just want to double check. How do you charge for this service?
Our licensing model is currently per physical server, one license per Metal server and inclusive of all features. And we currently charge on a monthly subscription model that includes 3 different levels of support. That's really the only thing that is selectable by the customer, or that needs to be selected by the customer, or which level of support they want to apply.
Is there other complementing software solutions that you work with or partner with?
We have a pretty broad set of ecosystem partners that across a number of different use cases across whether it's networking functions or artificial intelligence or computer vision. So we do have an ecosystem of partners that bring applications that allow us to turn the Nodeweaver platform running on Equinix Metal really into a solution.
Yeah, but just to add on to that, really any application, is if it runs in a virtual machine or a container, will run on top of Nodeweaver.
Marcus or Jeremy, and I think you jumped on a little late, Marcus, so I don't know if you want to.
Yeah, sorry, I missed some of the intro. Yeah, I'm curious what kind of applications you would typically demonstrate with this. Like, and I missed the early part, so I'm not sure if Kubernetes was mentioned or not, but that's always the buzzword I'm curious about.
Yeah,
Yeah.
absolutely. Kubernetes is. Go ahead, Carlo.
Yeah, we actually are designed to cover a whole range of applications that go from traditional VMs, which are still quite used by our customers. Even some of the VNFs that are used by some of our customers are still deployed as virtual machines. We do have our own CNCF certified version of Kubernetes that is capable of auto-scaling. So it's, as the rest of Nodeweaver, it's a single-click activation that automatically sets up everything that is needed for clustering and storage management. We do have the ability to run containers as well if the application does not require the full Kubernetes capabilities. In a sense, if you need a simpler solution for smaller deployments.
The way, and another part that I may have already missed is what your deployment pattern is, if you're using iPXE, or which if you're using one base image and then you're replacing it with another, how you provision nodes in layer 2 environments.
Yeah, Node are provisioned in, we do have multiple ways of provisioning nodes. We have an installation URL that points to a very small ISO image that can be used with IPMI. So you can basically net boot it and it will download the installer and flash it. It can be deployed through an image that can be flashed on disk, as we saw in the beginning of the demonstration. It's a single one-liner that performs all the installation for you. For let's say not your specific case, but we do also have a USB installer that is designed for physical deployment outside of data centers or edge locations. The update process is based on differential images. We distribute encrypted and digitally signed Delta images, so there is no actual need for downloading a new image every time that there is an update. And the system provides the ability to perform update without requiring reboots.
Okay.
Curious.
Oh, sorry.
Yeah, I mean, I can keep asking questions if you like. The Kubernetes side, I'm curious if you've invested or investigated in cluster API as a way to set up auto scaling within these groups. I'm also curious about any any difficulties that you may have run into with using the Metal platform, any hurdles that you had to overcome, areas that you thought that the platform could have been
no, actually, it's one of the best platform we managed to use. And I'm not saying this because we are in a call with Equinix, but it's actually a simple, well-defined and well-documented platform. So it was actually a breeze for us to adapt it. We are adding a layer that emulates IPMI and Redfish on top of our virtualization layer, which allows to use cluster APIs to manage the virtual resources. This is something that we expect to be available in the next 2 or 3 months maximum.
Great. Yes.
This is a very common request. It actually comes more from the software vendors that still require a sort of a manual process to perform installation. There's the ability to do IPI emulation and to connect to the virtual screen allows to script and automate the installation of services that would require a manual processing or someone at the console to perform actions. Basically, this allows us to add cluster API support for free.
Okay, this is awesome. Thank you so much. Any other questions from the Equinix side?
Not on my side. This looks great.
If I can just add a bit of context to the screen that we are seeing right now, which is, let's say, what drives most of our work. As you saw, Tom formatted and added a second node to the cluster, but actually you don't have to do anything. The system identifies the node on its own, replicated the data automatically without requiring any user intervention. That happens for everything that regards a Nodeweaver cluster. We handle all the physical layer in an autonomous way because the idea is that if you have to manage one side, this is something that can be done manually. If you have to manage hundreds of workloads in tens of locations, it becomes a real time sink. So everything is handled by the platform. You will just receive a notification or an email if something happens that requires your attention. For example, if you lost so much of the storage that the system may think it's too risky to continue. So it does have its own probabilistic engine that indicates whether there is a probability of failure in the future and will warn you if it goes beyond a certain threshold. That's the only area where you basically an intervention is needed, because at that point you need a physical presence to, I don't know, swap hard disks or change a network card or restart a server or switch it altogether.
That's very cool. It seems like you're also ingesting a lot of functionality into the platform. It does so much. All right. Well, I'm also really happy to hear you had a great experience on Equinix Metal. I hope that continues and that your customers can see this as well. Do you have any wrapping up comments from the Nodeweaver team that you may want to mention before I end this recording?
I would just wrap it up with saying that from our standpoint, we feel we're very complementary because, as Carlo mentioned, Metal is so easy to use and so easy to work with. And hopefully you can see that our entire philosophy is in line with that same idea that it needs to be very easy to deploy, very easy to use, because the system itself is automating so much of the interaction between the hardware and the application. Even going so far as a very simple licensing model. So everything that we do across the board is designed to be simple to use and understand and consume. So hopefully that's the alignment and the experience that your customers will have as well. But thank you very much for your time today. We really appreciate the opportunity to present this to you and the opportunity to hopefully take it to market together and provide a great new expansion of opportunity for Equinix Metal customers.
Awesome.